In this video, we'll cover brace expansion in bash shell, which is one of the possible ways to perform shell expansions in general. And brace expansion allows to generate arbitrary strings in bash, and these can be very practical for generating mocked data or dummy data for running some tests, for instance. There are two main possible ways to perform brace expansions. There is the pattern-based brace expansion and the sequence. The pattern-based is just a comma-separated list of strings that need to be combined according to a desired pattern, and this combination would allow to generate some strings that can be used in particular cases. And the nice thing is that the pattern-based expansion, or actually both type of brace expansion, can be combined with some prefix or suffix depending on the use case to build like complex paths or to avoid redundancy. For instance, let's say we want to check a specific set of commands in the USR bin directory. We know that if we just run ls/l/usr bin, the list of commands is quite a lot, because this is where all the binaries or installed binaries goes in general to be accessible from the system path, and all the core utils commands are also generally in the USR bin directory, but we just want to have the listing of lx or mcat mwc, for instance. A different potential way to implement this, we can try to find some complex combination with grep also to make this. But one of the easiest way to perform it is just to use brace expansion. Because with brace expansion, we can say, okay, we want to list the USR bin directory, but we only want to list, for instance, ls in the bin directory. So we will do it the verbose way first. And then in the USR bin, I want to list the rm command, and the USR bin, I want to list the cat command, for instance, and then ls will print those, which is all fine. But this is quite repetitive, yeah, because the USR bin is the same, and we kept repeating it. And this is one of the use cases where brace expansions is very handy, because we just need to specify ls/l/usr bin, and then we open the braces and list the commands that we want to list, like ls, rm, and cat. Notice that the braces should not be quoted, and the commas should also not be quoted for this to work properly. Yeah, that is the basic rule for brace expansion. The braces should not be quoted, and the comma should not be quoted. And then what bash will do is to use the prefix and automatically repeat it, and for each list or commands or pattern listed between the braces, the shell expansion will generate the full path for us. If we run this, bash will the ls command will just list those specific commands that we listed. And to see it in action, we can just, instead of the lx, replace this with the echo command, and then we see what is done. The shell expansion generates the path to match each of the pattern that has been listed between the braces. And this is one of the typical use cases, very handy to avoid repetitive paths in strings, and it can also non-existing paths as well. So let's say it's a completely just right here weird, it does not exist, but it will still be generated because there is no syntactic validation that is performed, and there is no path validation, nothing. There is no validation at all, because for bash, this is just a basic string generation that is being done from the bash expansion. Oh, not the bash, from the shell expansion. So that's one way. It's possible to nest the brace expansions, to combine them to have like very customized patterns. So in the second example here, for instance, we want to print, let's say, a set of custom usernames for some test purpose. And we want the username to start with T and B to be combined with O and I, and always end with MA. So what will be done is that for T will be combined with the two characters here, or there can be strings also, do not have to be characters. So T will be combined with O and will also be combined with I, and then the suffix will be added. So we'll have Toma and Tima as an outcome. And B will also be combined with the two characters in the following braces, and the prefix will also be added. So at the end of the day, we have a combination of username starting with T and B combined with O and I. So we can add, let's see, E and U, for instance, to have a more broader range. So this is the typical example, and it can be like multiple level of braces combination, and all it's like a multiplication kind of a structure. Yeah, and the string corresponding to each of its expansion will be generated an outcome, and this we can use it for our test purpose. It is also possible to have a nested layer of brace expansion. So we can have, let's say we want some name to be generated starting with T and B, but for B we want it to be combined with the letters O and E. And this another level starting with the letter B that should be combined with I itself, combined with X and A. And we have the B level expansion, and then we have the T level, and all of them ending with MO, for instance. And if this is properly written, I think I have missed one brace. This close with this one. B should end with a parenthesis, at least a comma. And that's it. Yeah, so we have a set of names. All of them does not have some meaning, but this is how it's possible to generate a very customized pattern of strings by nesting multiple levels of braces. And this is one of the powerful features that Bash offers, to generate data on the fly. The other way to perform brace expansions is the sequence, and for sequence it's quite straightforward. We have a starting sequence, is a starting character or integer, an end character and integer, and an optional part that defines the increment. So let's say we want to generate values from 0 to 9 ... and 9, and we close the braces, and the values from 0 to 9 will be generated. And if the increment is not specified, the default is 1. So basically we have the value 0, 1, 2, 3, so forth, till 9 that are generated. But we can also add an increment. So we just need to add ... and then the increment step. So this time we have 0, 2, 4, 6, 8, and then that's it, because we have the maximum to be 9. If we have the maximum to be 10, then we will also have the value 10 printed out. Or it's also possible to have the start to be a character, ... to be a character, let's say date, and then we'll have all the characters from A to Z automatically generated. And we can also have an increment. The default is 1 naturally. We can have an increment of 2, for instance, then it's like every other second character that will be printed out. So A, C, E, and so on. And the nice G to Z with an increment of 7 gives out, just nice trick. With the sequence generation, we can automatically generate a whole sequence of either numbers or characters. But notice that it's not possible to combine, for instance, number and then a character, because this will not be understood, like how you should properly increment values from a number to reach a character. And if the expansion cannot be properly performed, it will simply be ignored. So the string will be returned as it is. So in this case, we will just have the string 1.0 return because this expansion is not possible. So the start and end integer or character should always match. They should always be the same. So if the start is an integer, the end should also be an integer. And if the start is a character, the end should also be a character. Every other combination that cannot be properly expanded will simply be ignored. So let's consider an example where we want some log files to be automatically generated. Let's say 100 log files, and this can be achieved using the touch commands from the core utils. It can be used to modify the timestamp of a file or to create a new file if the file does not exist. And then combine this with breadth expansion. So we want our log files all to start with the string log, and then to be numbered, let's say from 1 till 100. And then by executing these commands, we will have 100 files automatically generated. But notice that the log files are not all ordered, because the length of the numbers as prefix is not exactly the same always, so they are not like properly ordered. So this allows to introduce one possibility that the breadth expansion offer for sequence generation. Or let's say this, we want to generate numbers from 1 to 100, and then this can be done. But let's say that we want the numbers to have a padding to all start with to have the same length, for instance. And to achieve this, we can just add an initial 0 to it. Either we can do it this way here, and then all the numbers will be generated with like a padding of zeros to have the same length. And if we have multiple one defined, then the longest one would be used as the default for the numbers to be generated. And this can allow us to have all our log files properly ordered. So first we want to remove all our 100 files. So let's use the rf log, and we want to remove everything. So let's check. Okay, they're all gone. And then we want to use the touch command again to have our logs generated, and we want the hundreds to be prefixed to have 0 padding, maximum length of 3, and then this way we can check again, and our files are properly created and all ordered with a 0 padding when needed to make the length match a length of 3. So yeah, that's quite a very nice way to guarantee that the length of the values that are being automatically generated are like of a specific length, for instance.